Okay, so the last thing that we're going to talk about is converting from degrees to radians. So what you guys need to realize is that degrees, which is what we've been working with, 90 degrees, 180 degrees, 60 degrees, degrees and radians measure the exact same thing. It's just a different way to measure them. So like an example would be we use inches, somebody else would use meters. I guess meters are really big, inches and centimeters. So they still measure distance, but they're just different ways to measure distance. That's the relationship between radians and degrees. Okay, so what are radians? Well, a radian is a pure measure based on the radius of a circle, and it represents the angle made when we take the radius of a circle and you wrap it around said circle. So if you have a circle here, this is the way I understand it, you've got your radius, okay? The radian is going to be when I take this red radius here and I run that radius up the circle, it's going to be that angle measure. Okay, that's the way that I understand it. Now, so some of you guys are going to be like, well, 1 radian equals how many degrees? I looked it up the other day, and it was like 50 something, I think. But really, the thing about radians is that when you're talking about like 1 radian or 2 radian, that really doesn't matter. What matters for radians is using pi, and that's kind of where our trig will start rolling in, which if you guys are thinking about circles, pi should make sense because we use pi a lot when we were talking about circles. So this is kind of when we make that switch from trigonometry being about right triangles to now all of a sudden trigonometry is talking about circles when it's talking about its angles of rotation. So the big measurement that you guys need to know is you need to know that pi radians equals 180 degrees. Okay, so if I was talking about my angles of rotation like I did earlier, I could move my terminal side over to here, and I could say that's 180 degrees. Okay, or I could move my terminal side over here, and I could say that that has pi radians. Okay, that would be what its rotation would be. All right. So we are going to work on converting between radians and degrees and radians. So the way that we are going to do that is we're going to go back to converting measurements. I think you guys have done this in Algebra 1 before. I know that you guys did it in middle school science class, at least with Mr. Prather when he was here. Okay, but you guys would start out and they would want to convert like feet per second to miles per hour. So let's say you were moving at 10 feet per second and you wanted to convert it to miles per hour. Okay, so the way that we would do that was we would multiply by, I can't remember what they called these, conversion factors? Oh, yeah, it's down below there, conversion factors. Okay, so I would need to know what's the conversion factor between seconds to hours. Okay, well, let's say I would know that 60 seconds is the same as 1 minute, right? And then I could say that I know that 60 minutes would be the same as 1 hour. Okay? And then you guys went through and you canceled your canceled your labels. So I canceled my seconds, I canceled my minutes, okay? And now I'm left with 10 feet per 1 hour. Whatever I found would be 10 feet per 1 hour. Okay? When I tried to cancel my feet, 5,280, I think, feet are in 1 mile. I hope that's right. Okay, so then I would go through and what could I cancel? Well, I could cancel my feet, okay, and I'm left with miles. So then I would multiply straight across, okay. So that's what we're going to be doing when we are converting from our degrees to radians or our radians to degrees. We're going to be using conversion factors. The nice thing is that when you guys were doing these things up here, there are a whole bunch of different things you have to remember. The only thing that you have to remember is right here. Pi radians equals 180 degrees. Okay, so the only 2 conversion factors that you guys are going to use is either pi radians over 180 degrees or 180 degrees over pi radians. And to determine which one you want to use, you just need to look at what you cancel. So if you are going from radians to degrees, well, radians have the pi thing, the degrees do not have the pi thing. So I need to make sure I cancel the pi thing. Okay, so we'll kind of do some examples to show you guys what it should look like. All right, so I've got 225 degrees, okay, and I need to convert that into radians. So 225 degrees, I need to convert it to radians. So I'm going to start out 225 degrees, right? And that would be over 1. Now I need to multiply that by the conversion factor. If the degrees is up top and I want to cancel the degrees, that means that I need to have degrees on the bottom of this here. Okay? So I'm going to have 180 degrees on the bottom, and up top, I'm going to have then pi radians. And remember, the reason that I know I want to do that is I need to cancel these degrees so that I will now have it in radians. So I've got 225 degrees times pi radians over 180. Okay, I cancel my degree things now. So now I have 225 pi radians over 180. Okay, and I'm going to want to simplify that, right? So 225 pi over 180, they're both divisible. They are both divisible by 5. So 225. Are they more than? Oh yeah, they're a lot more than that. Okay, I just plugged in my calculator and reduced it, and I just plugged in 225 over 180 and reduced it, which gave me 5/4, which would mean that would be 5 pi over 4. I could have broken it down by 5 like I was doing, so 225 divided by 5 would have given me 45. So this is me breaking it down by 5. Would have given me 45 pi over 180 divided by 5. That would have given me 36. So 45 pi over 36. Those are both divisible by 9. 45 divided by 9 gives me 5. And 36 divided by 9 gives me 4. So the radians, 225 degrees is the same thing as 5 pi over 4. Okay? So I had to use this conversion factor when I was changing from degrees. Okay? And then once I got it down to this part here, I plugged it into my calculator to simplify it, or I divided by 5 on top and bottom, divided by 9 on top and bottom, and I reduced it down to that point. Okay? We've got negative 40 degrees here. I'd pause the video and try this one on your own, see if you can figure it out. Okay, so I've got negative 40 degrees. I can just put that little degree thing up there if I want to. Okay, technically that's over 1. Now the degree thing is on top, so that means the degree thing is going to be on the bottom down here so that I can cancel it. Okay, so that degree thing is going to be 180 degrees. And what goes on top? Well, on top it would be pi radians. Okay, and you don't have to write out the pi, or you don't have to write out the radians, you don't have to write out the degree. Okay, it just kind of helps to figure out what needs to go where. I don't know why I made that pi in blue. Okay, so now I can see what I can cancel. Well, my degree things are gone, that's good. I've got negative 40 pi. Negative 40 pi over 180. Okay, so I've got to reduce that. Negative 40 over 180. I could divide both of those by 4. No, I couldn't. I could divide them both by 20 though. 40 by 20 would give me negative 2 pi, and 180 by 20 would give me 9. So it's negative 2/9, or negative 2 pi over 9 would be what negative 40 converts to. Okay, and right now you guys really don't need to know necessarily what the radians mean. We're going to talk about that more in lesson 9-3, sorry. Okay, but right now we're just practicing on converting them. So this is how we go. This is an example of how we go from degrees to radians. Okay, so on this next slide, now I'm going to show you guys how to go the opposite way. Okay, now we've got radians up here. I've got radians up here and I need to go to degrees. Okay, so pi over 4. I need to multiply this. Okay, now remember, radians have the pi in them. The degrees do not. Okay, so essentially when I'm dealing with this here, I need to get rid of that pi. So if I need to get rid of that pi, I need to have pi on the bottom. So that's pi radians on the bottom. Okay, and up top, I've got 180 degrees. And again, you don't have to write that radians there. You can just think, anytime I see pi, it's talking about radians. Okay, so I've got pi over 4 times 180 degrees over pi. My pi's cancel, which is exactly what I wanted them to do. when I do that, that gives me 180 degrees divided by 4. 180 degrees divided by 4, plug it in your calculator, gives you 45 degrees. Okay, so pi over 4, same thing as 45 degrees. Okay, I'd pause the video again, try and do your negative 5 pi over 3. Okay, hopefully you paused the video and gave it a shot on your own. Using our conversion factor here, you're going to use the pi is on the bottom again. I know that because I'm trying to cancel my pi's. So pi is on the bottom, which means that 180 degrees has to be on the top. Just kind of a warning here. If you have that negative out in front like you do, I would go ahead and move it up to the top. So I'd make this like a negative 5 pi over 3 just so that you keep track of where that negative is. You don't have to do that, but I could see some people getting confused. Okay, pi's cancel like I want them to. I've got negative 5 times 180, which gives me 900, a negative 900. Gives me negative 900 degrees, okay, over 3. So I'm going to take negative 900 divided by 3, and when I do that, I get negative 300 degrees. So we found that negative 5 pi over 3 is the same thing as negative 300. Okay? So that's it for the lesson 9.2. Okay? Your guys' homework is going to be on page 608. Numbers 11 through 30. If you do not have your textbook with you, I went ahead and scanned in. So if you click on the link that I have on the website, if you click on that link, you will go ahead and see all of the, I just scanned in the page. I'm sorry, I don't know why I'm struggling to think right now. Okay, so, but there's your guys' homework. Do this on a sheet of notebook paper. If you have graph paper, that might work better, but either one will work for you guys.